Okay, now with that we can see the previous this is how the rod will be okay, with that particular scenario you can see that we divided this to the segment of this, the rod, similar rod. Okay, can we calculate this x every segment here? Okay, can you imagine this is u 0 location 0. I start with the 0. What is the solution that I will get here? Can you see that? Sine 0, x is a 0, right? Therefore, I will get the whole thing 0. Okay, it's comply the first boundary condition as well. Okay, we cannot challenge the boundary condition. Remember, we cannot challenge the boundary condition, and after that we cannot challenge the initial condition. First you need to comply. Whatever you are doing, you must comply the boundary condition first before you go to the initial condition, because boundary is already fixed. Then initial you are starting, then you are checking for the rest. Therefore you cannot set the initial condition before boundary condition. Boundary condition must be set before IC. Okay, you must remember that. Okay, in this particular case we are already 0 and we are comply the boundary condition. This is a boundary condition anyway. Okay, we cannot challenge that. Okay, the next thing, u and 0.25. okay, 25. What is the, and when I place what you call 0 in the initial state, in the initial state, remember this is in the initial state, 0, what is the sign? 0.25 pi. Okay, which it will give you the solution as what? What is the solution that you may get it for that? Calculate. You need to use a calculator. 0.71. Okay. What is the u 0.50? Okay. Okay. Here you will get the solution as sine. Okay, sine 0.5 pi. Therefore you will get solution as 1. Okay, what about the u? U 0.75. again as a repetition kind of things. Okay, again sine 7.5 pi. You get again that same 0.71. Okay, what about this? Sine u 1 0. 1 0. Can I challenge this? See, boundary condition has been set. I cannot challenge. I cannot challenge this. It's a 0. But coincidentally, sine 0 1 pi also is a 0. Coincidentally, remember, is a 0. But again, you cannot challenge boundary condition. Okay, you cannot challenge boundary condition. Boundary condition must be complied. Okay, if this is the case, can I start working on the scale? Okay, in order to do this, I will recommend you to design. Okay, I will recommend you to design what I call it as chart. Okay, you must make a table. Don't do this continuously. You cannot do this way. I'll recommend you to come up with a table. Come up with a table. You see the table, it has a model. Okay, I'll show you different style of writing the things. Okay, the first del t. Okay, del t. We call it this as a j. Del x. I call it this as a I. Okay, I. Okay, now just split. Okay, t. Okay, I haven't give you the t, how long the t can go. Okay, here I put it the increment here 0.1. but it can go on and on and on. Let's say I control the t. It will be given. Don't ask me again. Is it? Can I assume myself? Cannot. You cannot assume. This must be given. This must be given. Okay. In this particular case, let's say I set the t is 0, 0.1. Okay, I set this as a 0.375. Okay, can or not? Sorry, t, t. Del t, t is I set to this. Okay, can you see the progress now? Let's say, t, sorry. I am very sorry. Again, 0, t, 0.5. Because its increment is a 0.1, 0.2, 0.3. It cannot be like this, okay? It cannot be, because I already, wrongly copied this. Okay, now, when this case is 0.1, still wrong. It's maybe I'll try to go up to 4 level. Okay, you can go for up to 4 level. Okay, now with that, okay, you see I set this one is a 0. Del first initially begin with a 0. Okay, progress 0.25, progress 0.225, 0.5, 0.75. Okay, up. Okay, 1. Okay, 1. Second, what is the t progress? The t will progress 0, 0.1, 0.2, 0.3, 0.4. Okay? Agree? Can or not? This is the table. Okay, remember the t progress based on the difference between the size of the t del t is a 0.1. Okay, the change of this here is a del x. Okay, is moving on like del x. We need to change for the del x here. This is again for the del t. This is del t. The changes here refer to the del t. Okay, boleh, can design the table? Okay, can. So far, okay. Now, go to the how do we fill up this table. First, follow the boundary condition first. Boundary condition, you must comply. For the x equals to 0, x equals to 1, we don't care what is t. Okay, t can be anything. Again, I reply, it can be 0, 1, 0, 0.1. We don't care, but the things will be 0. Is a 0, 0.2. It's a 0 because it's very clearly stated here. Can you see that? 0 t. T can be anything. Okay? Can be 0.1, 0.2, 0.3, 0.4, whatever. Still, it must comply. Again, if for this particular case, you want 0.1 must be 0. You want 0.2 must be 0. Okay, very clearly stated. Okay, the boundary condition very clearly stated. Therefore, we just go here. Okay, fill in everything here. Since x is a 0, it's all 0. Set that first. Set. Okay, you don't care. Don't see anything to do that. Boundary condition must be fulfilled first. Remember that. Okay, what about 1? Del x is a 1. Therefore, 0, 0, 0, 0, 0. Okay? you must fill up this first. Then only you need to check for the rest. Okay, now you see here 2.0 here. Okay, 0, 2.5. This become 7.7071. Okay. Okay, if you cannot understand this ij concept, okay, I explain to you what is ij actually works. Okay, this is ij. Okay, if this is I, this is I plus 1. If this is I, this is I plus 1. Remember, it's a one-step hit. It must be I plus 1. If this is a I, this is a I minus 1. This is a, if this is a what do you call, this is a I plus 1. This is must be I, and this must be I minus 1. Okay, remember, that's how we are using the logics of this I and j. The logic is same. Okay, now you see 0.5, we have done the smart portion also here, 1. Therefore, if it is a case, it's a 5, 0, answer is 1. 1, and this will be 0.707 071. Okay, can or not? This is easy, right? Okay, similarly, how to calculate this here? Okay, in order to calculate here, I will tell you some simple technique. There is a simple technique. You need to use 3 combination only. 1, 2, 3. How do I know? This is I minus 1. This is I. This is I plus 1. Can you see that? Okay, now we go. Okay, we go. You see how am I applying this rules here to calculate the logics. The first one, see the formula. You must understand this formula first. See, the formula is very straightforward. I plus 1, I. You need to use, where is I minus 1? There is I minus 1 is missing here. Suppose this one is must be I minus 1. Yeah, it's not a plus. Mistakes, you see. You can just apply the work straight away inside here. Okay, but you see, I'm going to use the logics here. Okay, okay, I j plus 1. What is I j plus 1? Which one is I that we are referring? Okay, this is I. This is I. J plus 1. Okay, we're going for this one, j plus 1. Okay, if we take here, this is I. This must be j plus 1. Okay, this is a ij. Okay, ij. If we pick this as ij, you look at this one. I will write in a simple way. If you still cannot get this, what I'm trying to say, okay, let's say I'm writing this. I is a 2.5, right? And here 0. I'm interested in this. Okay, look at this. I'm interested in this 0.25, 0.1 here. Okay, now what I'm referring to here, I j plus 1, right? This means j plus 1. This is I. Okay, if I call it this is I, this is a j plus 1. You see what suppose I need to do? I need to use lambda. Lambda calculation here. This formula lambda is here 0.16. Therefore, I just say 0.16. No problem. Okay, go one step further. Oh, you all cannot see, Why I didn't pull that. Okay, now you see wow. Okay, can I choose this way? Easy. Okay, you look at this one first. Okay, I want you to see this formula together. One, easier for you to see what I'm trying to write here. I lambda, okay, u I plus 1 j 2 u I j plus u I minus 1 j, okay, u I j. Okay, look at this one. Now if I choose 0.25, this means I'm referring this as I, and I'm saying 0.1 as a j plus 1. Okay, now lambda we already calculated 1/6. What is ui plus 1? Okay, what is ui plus 1? Ui plus 1, if remember, if 0.25 is I, what about I plus 1? The I plus 1 is here, this 0.5. Okay, this means you need to write this as a 0.5. Can you see what I'm doing here? Okay, 0.5. J is a, if this is a j, 0.1 is a j, the j is of course 0, right? 0. Okay, divide minus, same as that. You can do the similar work as 1 by 1, but I may recommend to use my formula, that which is very fast, you can calculate. Okay, doesn't matter anyway, whatever. Okay, you just, as long as you can understand. Okay, okay, we follow this because this is the book. Okay, the formula book will give you u is a z, what is that? U is a ij is a 0.25. First I'll write, don't worry, it's look complicated in the first initial state. I agree with you, but don't say this is very difficult. First time only, I'll teach you the simplest method there, but the first time I wanted to show you the complete one first. Okay, what is I minus 1? I minus 1 is, you need to refer to the below. There is a 0, and because I is a 20 and j is a still same, it's all the while is a j is a 0, therefore u same as a 0.25 and 0. Okay, can you see that? Can you see this first? Okay, now we just substitute the value here, 0.16. Okay, what is this? Now you see what I'm trying to pick here. 0.5 is 1. I'm pulling this out. Can you see that? This is 1. 2. 0.250. I'm pulling this. There is a technique coming out here. Okay, I'm pulling this results here. This results here. See, I'm pulling this results here. Okay, pulling this results here. Therefore, 2701. Okay, plus 0, 0. Okay, 0, 0. Pulling this results here. That means it's a 0. Okay, what about u? 025? 025 with the 0, I'm pulling this again to the solutions here. Okay, therefore, it's supposed to be I made a mistake here. This is I. Yes. Okay, we are pulling this results here, 0.71. Okay, altogether you get a solution as 6408. Okay, Can you see that? This is a 0.6408. Okay. Now, if I can calculate that way, what about the next one? The next one here, this one. How to calculate? Okay, I'll teach you the same model. See, you go, you identify what you wanted to calculate. Here is a 0.5. Okay, 0. I'm taking the same model here. You can see 0. I'm interested in 0.5 and 0.1. Okay, 0.1. Can I calculate that? Okay, use that same 0.16. Okay, now you see I'm using the simple technique to calculate this portion. Pull this. Can I get different color pencil? Tada. No. Okay, you pull this inside here. Okay, the first one is pull the first point here. The first one is always here, or one step here. This one, sorry. Always we go to the front first. 1 minus 2 to this 0.7071. Okay, plus here. Here, right? This one, sorry. 1. This one go here. 0.7071. Close. Plus same position 1. Okay. If we calculate that, this one will give you 0.414. If you use my style of calculations that earlier that I recommend to you, you no need to, this one is a disturbance here, right? You can arrange back and you can just substitute in this model that very fast you can calculate 1, 2. What about this? How to calculate this? This one is 0.414. Okay. What about this? You need to pull from here, here. Can you do that? Try and see. Okay. Then this is how you should calculate the whole thing. Okay, again I write for you. You try and you can try your work. Okay, this one is 0.75, 0.1. Okay, how to calculate that? You need to use the 0. Okay, 0.16. Use here 0. Pull this one 0. This one minus 2. This second 2, 0.7701 plus 1 plus 1. Plus not 1 here. This one 0.7071. Can you calculate that to fill in here? Similarly, can I calculate the same way as this to move on and fill in all these things? Can you calculate that way? Possible, right? Oh, cannot see, yeah? Okay, done. Can or not? Can, Okay, I'll give you two more examples with the complete, this thing. I didn't complete this one. I want you all to complete, but don't worry. For the two more, I will give you the complete answer. Okay, I'll give you the complete answer because I want you to fill up lah. Just taking this as an example and just try to fill in this. Okay, fill up this. Is it easy? Okay, or you can use my style of formula. Okay, the formula that I recommend to you is this. The formula that I recommend to you is this one, which is I j plus 1. Okay, you go one step higher. Okay, now we use I organize back everything according to the order. Therefore, it's easier for you to handle this problem. First middle point. You can do this u I plus 1 j. Okay, the first one plus. Okay, if you cannot see what I'm trying to do here, okay, wait, u I minus 1 j, okay, minus 1 minus 2 pi. If you can calculate one time, one go, very simple. And this will be u I j. This is the formula that I recommend to you. This, see, very straightforward. Negative 1 minus 2 lambda. Lambda is missing here. Yeah, there is a lambda is missing. Okay, you can make it this 2 lambda. Okay, lambda here, lambda, this 2, this is a lambda is here, because it's a lambda here, this is a lambda. You can use this. Therefore, the substitution, you just substitute for this value, you just calculate here, you just calculate here. Okay, if you want to use a single model like the previous example here, can also, no problem. Okay, you can just use this one, and you can it's a simple, this one, look, I don't know, 2 times you need to calculate here, you need to use calculator here a little bit more, but easier, you can pull the things organized and you can calculate the whole thing this way. But depends, I leave it to you. Whatever the method that you prefer to do is, I leave it to you. Still, as long as you can understand the logics, then you can handle. Okay, either one of the way is still simple. Okay, still simple to handle. Okay, with that, now let me go for another example. Okay, another example 2. The example 2 is a ut equals to kuxx, and I purposely give you the boundary condition a little bit complex. I call it this as x naught. The x naught says 0. Okay, this cannot be same. Okay, I purposely break it this to 2. u0t is a 10 and 60 18. First time you are seeing something different, right? It's not encapsulated, right? And x0 is x2 base 2, and x can go up to here, and t can progress up to 0.375, and I give you del x equals to 1 and del t equals to 0.125. Now it's a look complex. First, let us understand this process first. Okay, can I identify how to calculate the lambda for this? Can, right? Imagine kalau if you cannot see this, you imagine this is imaginary anyway, you divide by the del t. You can imagine this is a del u del t. Okay, this one is a k, del 2u, this is a del x2. Okay, you can imagine, it's a kind of imagination. Now you bring it this, the del u can be k del t divided by del x. Now you know how to create this. This makes sense, right? This makes sense to you, right? Okay, I bring it this. It's not cannot these things, but I want, my interest is this lambda, how to create lambda. Therefore the lambda is k lambda t del x2. Okay, this will give us 0.25. Okay, how to grasp the logics of this? Okay, in this case, you need to make the segment beginning here u0t equals to 10. Is not 0, remember? Okay, I need to break that. How many breaking point is required here? This is 0 to 7. Okay, I need to break it that to, if this 1, 2, 3, 4, 5, 6. Okay, this is yeah. Okay, 0, 1, 2, 3, 4, 5, 6. The highest x can go is a 6. Yes, the highest it can go is a 5, 6. Okay, you see what is the 6 here? 60 is a 18. 60 is equals to 18. Can I? Okay, can. Okay, now we split something here. Okay, this is a del x, as you know. Okay, what is this? How do x0 for the initial state? You can design later one by one. You can imagine this is a x. How many 1 do you able to split here? u10 is a 1 over 2. u2x 0 is a 2 must go here. 2 by 2 is a 2. u30 is a 3 over 2. 3 over 2 to 2, and etc. is going like that. Okay, can you see this? Okay, I'm pulling this in. Okay, now can we design the model table for this? Okay, you see, purposely I'm changing the previous things purposely. Don't worry. Okay, this time I want to change to this del x to this side, and del t to this side. No confusion. You may say, sir, why you don't want to follow the convention? No, the reason you cannot stick to certain time. Some books, they may use different style. Okay, I want you to adapt to this kind of culture first. Okay, then I split purposely. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, now break that. 1, 2, 0, 0.125, 0.250, okay, 0.375. Okay, agree? Can follow? Okay, first thing, as I told you before, you must fulfill the boundary condition. This is a boundary condition. You cannot challenge boundary condition in any way. Again, I repeat several times. UT10, 6T, 18. Look at this. X here, del x. This is del x, you know. If del x 0, the whole thing must be 10. Done. Okay, if x is a 6, t it must be 18. 6, you go here, 6, all must be 18. 18. You must fill up this first. You cannot fill up other. Okay, the next, with that, can I filled up for the first logics that I want you all to. Okay, look at this. 1, 0, off. Okay, can I see that? 1, 0 is off. 0.5. Small change. I know some of you don't feel good, so why are you changing like that? Please, because I want you all to a little bit adaptable to the model that I want. This 12.5, okay? Okay, how do we start? Okay, earlier I said this, I need to pull from this 3. What about now? I wanted to find out here. This time you need to pull from here, here, here. Can you see that? 1, 2, 3. Okay, first you need to pull from here, second, 10. Okay, you see, how am I doing? Okay, in this particular case, if I choose U1, 0.125, okay, the straight information, I use the standard calculation, 0.25. Can you see that? Okay, the first one, pull 2, here, 2, done, minus 2, 0.5, this one. Why I pull times 2? 2 is fixed ID. This one plus 10. Okay, plus this one again, come back, 0.5. Therefore, you will get the logics that in this particular case here, it's up to you how do we wanted to calculate the results, and you can solve the problem. Okay, when you calculate that, now you get a 3.25. 3.25. You need to pull from here, this side. Okay, then you need to fill in this 2.25, 4.75, 8.25, what is this, 12.75. okay, I make it a little bit faster. Okay, same. This is the model that previously we started using, right? We use to go the front one, just pull, and next. Okay, again I show you this model again. Okay, this. What about this? Again, similar. In order to calculate this, pull this out. You must refer the x first, progression of the x, because x is a progressing here, right? Always refer x. You cannot go t, you cannot go to the t, the next t cannot. You cannot use that one, because always x is a reference points that you need to use, because boundary, this moving this way, then only the time will move up to the clock, right? Okay, how to calculate this? Use this 1, 2, 3. Okay, how do you calculate this? 1, 2, 3. Can you pull that? Can, right? Similarly, you can calculate this. I hope that you got the logics. Those are following my lecture, I'm very sure you can complete this one very comfortably. 9375. This one is 5625, 398, 5.4, 8.73, 8.73, 13.0. Okay, 13.0. Can can. Again, you can give a try for one more model here. 2, 0.1.25, same here. Calculate and see first. Okay, same. I'm trying to give you the idea. 0.25. Okay. Pull this 4.5, 2, 8, 2, this one, 2, okay, plus 0.5 plus Okay, 2. Okay, then we can calculate the whole thing for 0.5, 1. 1 times 0.2 point. Yes, okay. Can boleh can. Okay, the last one, last example to close this chapter. Okay, last example 3. Okay, I'm working on the same question. Imagine that I'm working on the same question, but I'm changing slightly. Del x, make it 1. K, make it 2. Del t, I'm making that as a 1, 2, 5. The u t, same as 10. U 60. Now you see. U 5t, same.